All right, let's take a look at our lesson on probability. So let's look at, we have several different formulas. You won't have to memorize these formulas for your assessment. Let's kind of get a feel for what each of them means. The first one is just a simple probability. And basically what we're looking at is a fraction of what we want. So what we want to happen over the total possible things that can happen. So an example of that, just a simple example. What if we wanted to roll a dice and to get a 1? Well, let's say to get a 2. Okay, so how many 2s? This is a regular dice. How many 2s are there on a dice? There's just 1. And how many different numbers were on just a regular dice? There's 6. So then we'd have the chance 1/6 of getting a 2. So that's just simple probability. Then we've got the probability of the union of two events. And so this little notation, this is a set notation, it means union. In words, it's A or B. A or B is union. What would we do? We would get the probability of the first event. We would add that, the probability of the second event, and then we would subtract from it the probability of the intersection. So the intersection of those two events. Okay. So if the two events are mutually exclusive, means they can't happen at the same time. Mutually exclusive means can't happen at the same time. Then we wouldn't have to subtract out the intersection. There wouldn't be an intersection. We would just find the probability of one and add the probability of the other to it. Okay? We have an example of that. Then we have the probability of independent events. This is a probability of A and B. A and B. So for our purposes with probability, or is adding and is multiplying. That's just kind of a thing with probability. Or is adding and is multiplying. So if we want the probability of A and B, we would find the probability of each of those events and multiply them. An example of this would be like the probability of rolling a 2 and choosing an ace. Those are independent events. They don't really have anything to do with each other. Okay, then kind of a strange one, the probability of a complement. A complement is like an opposite. It's like an opposite. And the mathematical notation for it is like A with an apostrophe. So what we would do, if it's kind of really complicated to find the probability of A, then, and it's easier to find the probability of its complement or kind of like its opposite, we would do this scenario. We would do 1 minus the probability of A. Okay, so let's practice these now. We've got some examples to do on the next page. So the first example, we have 2 6-sided dice. What's the probability that the total of 2 dice is 7? So, we don't have a formula that just says, oh yeah, here's the formula you do for this. We have to actually figure out, how many ways can we get a sum of 7? So let's just do like a chart. Here's my first dice, here's my second one. Let's see, what could I do? I could have a 1 on the first one and a 6. That would total 7. Well, this would be different if I had a 6 on the first and a 1 on the second. That still would total 7, but that's a different event. Okay, so what else would add up to be 7? Let's see, a 2 and a 5, or a 5 and a 2. Let's see, a 3 and a 4, or a 4 and a 3. Is there anything else? No, nothing else. Let's count those up. 1, 2, 3, 4, 5. There's 6 of those. So what do we want? We want one of those 6 things to happen. What is possible to happen? So the total things that could happen would be, I have 6 choices on the first dice and 6 choices on the second. So 6 times 6 would be 36. So the probability of getting a sum of 7 would be 6 over 36, or 1/6. Okay. Our next example is looking at finding the probability given some data. We want to know what's the probability that we pick an institution in one of the 3 southern regions. So let's identify first which are the southern regions. Let's see, here's South Atlantic, South and South. There's our 3 southern regions. So let's add up those. So 797 plus 294 plus 438. Okay, so let's see, what does that give us? That gives us 1,529. All right, so what do we want? So probability of southern would be, what we want is 1,529 over. Well, we would need to figure out the total, so we have to add up all of those numbers, which I did. Of course, you would have a calculator. 4,490. So that would be our fraction. Now that is a weird fraction. You could certainly leave it like that, or if you wanted to do a decimal approximation, that would be fine. Our decimal approximation would be 0.341. So that would be the probability that we would choose one of those institutions that are in the South. Okay, so let's take a look now at number 3. So this has to do with a lottery game where you choose 6 numbers from 1 to 44. Let's see, in any order. Ooh, okay, so this should ring some bells here. In any order. If we choose a number and we don't care about the order, we remember what that means? Yep, you're right, combinations. Well, that's exciting. We're going to combine combinations with probability, yay. All right, so what is the probability of winning the top prize when 1 ticket's purchased? Okay, so I just have 1 chance, 1 ticket, and of course I want it to be the winner. 1 ticket out of how many ways could I choose the correct combination of numbers? Let's see, how many numbers do I have to choose from? I've got 44 numbers to choose from. It's a combination, and I need 6 of them. So how many ways could I do that? Let's see, that would be 1 over 7,059,052. So you can see why I would rather buy a pair of shoes than buy a lottery ticket. So that would be 1 out of over 7 million different ways to choose 6 numbers out of 44. Okay. All right, let's take a look at this next one. We draw 1 card at random from a standard deck of 52. You know, every time I teach a lesson on probability, there's at least 1 person in the room that's never played cards before. So I'm just, in case there's 1 person in the room that's never played cards, I'm just going to go out to the side and just, you know, list some things. So how many cards are there? And just a standard deck of cards. There's 52. What kind of suits? There's 4 suits. We've got hearts and diamonds. And sometimes they'll ask you about red cards. So hearts and diamonds are red cards. Okay. We have 2 other suits. We've got spades and clubs. And those are black cards. And sometimes they'll ask about the probability of getting a black card. And so that would be spades and clubs. So if we have 52 total cards and we have 4 suits, let's see, how many would be in each suit? Yeah, we've got 13 cards in each suit. So let's list the 13 cards. Okay, so what do we have? We've got an ace, a king, a queen, a jack. We've got a 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, these 3 cards are called face cards. Sometimes they'll ask you the probability of having a face card. So it's important to know that 3 out of, each suit is called a face card. So that's just something, to know. In case you didn't already know. You probably already know all about that, but I just wanted to list that out. Okay, so here, let's take a look at this. So we draw 1 card at random. What's the probability that the card is either a heart or a face card? Or, that's that formula up above. That was kind of weird, right? We need the probability of a heart. We need the probability of a face card. We also need the probability of a heart and a face card. That's that. Let's remind ourselves up here. That's this one here. The 2 events that are the union of 2 events. Okay. All right, let's think about this a minute. So we've got hearts. Let's see, we have 13 hearts out of 52. Face cards, so there's 3 face cards in each suit. There are 4 suits, so what is that? That's 12 out of 52. Now, do we have hearts that are face cards? And again, we're talking about the whole deck. We're not just trying to narrow down to just a few cards. Like in the whole deck of 52, are there any hearts that are also face cards? And that answer would be yes, right? There are 3 hearts that are face cards in the whole deck. So we're going to use that formula. We're going to add together the first 2 probabilities. And we're going to subtract out that intersection. Why do you think we do that? I mean, because the probability of hearts and the probability of face cards, those 3 cards are included in both of those, aren't they? They're included in both of those probabilities. So there's been a duplicate going on. So we've got to take that out. We've got to make an adjustment for it. So when we do this calculation, we're going to get 22 over 52. Reducing that fraction, we get 11 over 26. And if we want to write it as a decimal, we can. 0.423. Which is kind of interesting, actually, which means that you almost have about a half a chance just drawing a card at random of getting either a heart or a face card. That's kind of interesting. Okay, let's take a look at number 5. A random number generator on a computer selects 3 integers from 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? Okay, so let's step back and let's just talk about one of them. So we want to just find the probability that one of them is between 1 and 5. So the probability that we have a number between 1 and 5. Okay, so how many ways could we get what we want? How many numbers are between 1 and 5? Well, 5. How many total numbers could we get? Well, it says from 1 to 20, so we could get 20 numbers. So the probability of getting what we want would be 1/4. Now we're actually going to do that 3 times. And we want to get that number 3 different times. We want to get a number between 1 and 5 the first time, and the second time, and the third time. We want to get to all 3 times. So the probability of doing that all 3 times would actually be 1 over 64, which would be like the probability of independent events, where we multiply those together. Okay? And the last one is the quite strange one. This is going to be the complement one. A manufacturer has determined that a machine averages 1 faulty unit for every 1,000 it produces. What is the probability that an order of 200 units will have one or more faulty units? Ah, the or more. Why are they doing that? One or more. What does that mean? Ooh, that means I have to figure out the probability that it's going to have one faulty unit, or two faulty units, or three faulty units. Am I done? No. Or four faulty units, or five. Am I done? No. Or six. I'd have to keep going till I got to 200. Ooh, that would be terrible. This would be a perfect situation where I could use the complement. Let's do the opposite of that, okay? Let's do the opposite. Let's do 999 units out of 1,000. And let's do that 200 times. Let's just do that 200 times. And that's going to give me 0.8186488. So now the probability of at least one faulty is going to be 1 minus 0.818648, which is 0.181. Way easier than doing all those others. That would have been, whew, that would have been rough. All right.